So normally, if you saw a molecule like ethane, right, eth, 2 carbons, an, all single bonds, e means you just have carbon and hydrogen. So you have something like ethane, you'd be used to seeing a Lewis dot structure, something like this. So if you were to look at the three-dimensional structure, that would look something like this, right? Now, it's a three-dimensional molecule. You don't always have to look at it from the side. You can imagine looking at this molecule head-on. So we're taking the molecule from the side, and we're looking at it head-on. Now notice, a couple things happen when you do that. First, the carbon in the front, the carbon in the front gets in the way and blocks the carbon in the back. So if you wanted to draw this orientation, what you do is, for the carbon in the front, you just draw a dot. You make it smaller, and the carbon in the back you draw as a big circle. So this dot is the carbon in the front, this dot is the carbon in the back. Now notice, if we go back to this molecule, you can see that the carbon in the front has 3 bonds, sort of in the shape of a triangle. And so you can draw those 1, 2, 3 in the shape of a triangle. Notice the carbon in the back also has 3 bonds, also in the shape of a triangle. This green one going back to the left, the white one, and the white one going down. So I can draw going down, up, and up. Now, depending on what bond you're looking through, what molecule you have, you can fill in what each of these groups are. So in this example, it's ethane, so these would all be hydrogens, but you could imagine them being other carbon chains. Looking at a molecule down a bond like this is called a Newman projection. A Newman projection. And the reason why you would ever do that, besides the fact that it's so fun, is to see strain that comes from rotation of a bond. Right? Single bonds can rotate, and as the bond rotates, it becomes either more or less stable. For example, when the bond is rotated like this and all the atoms are lined up, these feel each other more and repel each other. Like these green ones, they're perfectly lined up, and so they would repel each other. All these would repel each other, and the molecule would sort of push each other apart and be really unstable. As the bond rotates, they're further apart, and so they don't feel each other as much, and the molecule is more stable. So this is strain that exists in a molecule based on how the single bond rotates. So the advantage of a Newman projection is that it lets you see strain that's coming from rotation. Now there are at least 2 conformations you should be aware of. When the atoms line up like this, that least stable conformation, that's called the eclipsed conformation. The conformation where they are furthest from each other as they can possibly get, that's called a staggered conformation. So it can get trickier as the molecules get bigger, but that's the basics of Newman projection.